Hello everybody, I just got the news that Chang'e-6 Chang'e, this you pronounce in Chinese, 6 has just inserted to the moon orbit. The orbit insertion, we talk about this one, is not trivial. First of all, Chang'e-6 just left a couple days ago and already arrived the moon. That means from Earth's orbit to moon orbit, it looks like it went there directly and got into the orbit. And it takes less than 2 days. Okay. This you can do it only when you have a navigation system. Like a Chinese has a navigation system on Earth, 3 satellites and 2 satellite. This navigation system satellite on the moon. When you don't have, like India and Japan, what they do is they increase the length of this Earth's orbit little by little. It has to go through many circles and finally arrive and get into the orbit. When you don't have a navigation system, this is the only way. It takes about 1 month. Okay, so you have a navigation system or not, the NASA directly go without navigation system and just take a chance. What happened is, we talked about this one already. This is the moon, and when you come in, this distance r and the speed. So this is a basic equation. M is the moon's mass. If this r and v is just right, then it's getting to the correct orbit immediately. Okay, but maybe r is too far or v is too fast. What's happened is typically it goes ellipsis orbit. That kind of orbit insertion happen, right? And if its r is too small or v is not enough, then it's crash. But usually before it's crash, you circle around and crash. Okay, this is a crash, and NASA crashed many times. This India, the first time sent the moon, it disappeared around the orbit, and 8 years later it came back. That means this is a huge ellipsis circle. So this is very important. Navigation system determine v and r and make it as close as this equation. Okay, and that's the way you can do orbit insertion. We talk about orbit insertion because that's also related to this equation is used for rendezvous auto docking system on the moon. So what's happened is, after the lander collected soil, right, it's put into the container on this departure system, and this departure system go up and go back to the orbit, and this has to be docked with the satellite waiting in orbit, because this has enough fuel to go back to Earth. So after docking, the sample is transferred to this unit, and this system is discarded and only this one go back to Earth. Okay. So how do you do this docking, right? So what's happened is, first of all, orbit insertion has to be particular orientation. This is the south pole, and this is north pole of the moon. And when approach to the moon, it's come to either north or south pole. Then orbit will be side view, halo orbit, right? Because otherwise you cannot land on the south pole. You cannot go this way. This is like other way, you land here or here. But if you want to land south pole, the orbit has to be this way. So orbit insertion is very important. Okay, now the problem is you have satellite orbit, and this unit has enough fuel to go back to Earth. And when job is done, job is collecting a sample, this lander go back to orbit, and this orbit could be slightly different orientation. Okay, then you cannot do docking. The rendezvous is impossible. First, this has to be corrected. How you collect it? This side, you gently push this collector toward this orbit. The other way around here too. So again, you need a navigation system. In order to do rendezvous and docking. Well, this is the basic. Without this, if you do it on the Earth, the Earth can observe and measure the distance and speed and control the rendezvous operation. But on the moon, you cannot do that. It's all automatic. So they determine the position, and now each other's position here. Each other's position, and navigation system determine the position. So it's all software operation. Can you do manual rendezvous and docking on the moon? That's impossible, basically. Okay, it's a software does that, all of that. Okay, now once you have the situation, the orbit is aligned, and this is the module, return module, and this is the module came back from the moon. Okay, but docking window could be the other way. So how do you correct this? Well, what the software does is, in this situation, software move either one. Say move this guy out. So what's happened is, when this R increase, so the V decrease, so it will be slower than this guy, and this sample collector catch up and overlap the same position, and eventually pass. When it's pass, push this by rocket engine gently back to the same orbit. Then now you have a same side, the docking window on the same side. Okay, Then what you do, gently increase the speed. So increase the speed, orbit is going to be shifted, so you have to adjust that too. So everything is minor adjustment. You have to do the keeping in orbit and pushing forward kind of operation. It's all done by software. Okay. Then it's finally do the docking here. That's automatic docking. Auto docking process. Okay, then the sample unit is transferred to the return unit, and once sample is secured in the return unit, then return unit fire up the engine and go back to Earth. Okay, so near Earth operation, when it's come back to the Earth, near Earth operation, this return unit is going to separate this capsule because the fuels used up, and this is just the weight, extra weight. In order to make it lighter, this separate, and navigation system is going to tell you when it's separate, and once it's separated, again the orbit insertion. But in the previous video I explained this. You cannot just come into orbit in this case because Earth's gravity is too large, and this is going to accelerate like Mach 20, and in this speed, if you get into the atmosphere, everything burns like an asteroid. So what it does is intentionally make this V is Mach 20, and intentionally this gonna go elliptic orbit. So it's look like it's bouncing here. It's not coming here. It's bouncing. Okay. Then if you bounce too far, it takes too long time to come back. You have to be just right amount of bouncing. Then it's come back to the orbit again. Okay, this bouncing is necessary when it's come back. Return modules get too much speed by gravity, Earth's gravity. It's too heavy, and it's just the speed go up to Mach 20, get into the atmosphere, it's gonna burn. It won't be it won't survive. So you have to bounce once and lose the energy, this potential energy of the Earth, then come back to the orbit. And once it's come back to the orbit, then it's gradually descend and land on Earth. Okay, so this is a whole system. This is a very delicate system. Everything has to be controlled. This is purely software control, or docking software control. And the comeback, it's communicate with Earth and make sure the navigation system. So you really need softwares, huge amount of software development and navigation system in order to detect the exact location and speed. And they are the key for successful operation like this. Without those, you can do blindly, and sometimes it's screw up. And that kind of system, you cannot put the human on it. This has to be established and tested multiple times before human get on it and go to the moon. Okay? Okay, that's all for today. If you think this is interesting, please subscribe and click like and wait for the next video.